Ever looked out at the world and wondered why it has so many different faces? Well, today we're going on a global field trip to figure that out. We're going to explore everything, from the wettest jungles to the driest deserts, and uncover the simple rules that create them all. I mean, think about it for a second. Why is the Amazon a steamy green jungle, while the Sahara is a massive sandy desert? One place is absolutely bursting with life, and the other seems almost empty. What's the deal? It turns out the answer is actually pretty straightforward. There's one big idea that explains all of it. It's kind of like the rule book for life on Earth. And once you get it, you'll see our whole planet in a completely new light. And that big idea is the biome. So what is a biome? Simple. It's just a huge community of plants and animals that have all adapted to live in a specific climate. Think of it as the big picture label for any environment on Earth. Okay, so if biomes are the result, what actually creates them? Well, it turns out there are a few simple rules of the game that decide where every single biome pops up on our planet. First things first, we've got to get one thing straight. Weather and climate are not the same thing. Weather is what's happening outside your window right now. Is it sunny, rainy? But climate, that's the long-term story of a place. Its pattern over decades. Biomes are shaped by that long story, not by today's forecast. And that long story, that climate, is written by just two master architects: temperature and precipitation. How hot or cold a place gets, and how much rain or snow it gets. These are what we call limiting factors. They're the two big bosses that ultimately decide what kind of life can survive where. Now, this chart right here is the key to everything. It's basically the cheat sheet for all of Earth's biomes. Let's break it down. On the side, you've got temperature, going from hot up top to cold down at the bottom. Across the top, you have precipitation, from super wet on the left to super dry on the right. See how every biome fits somewhere on this grid? Hot and wet gives you a rainforest. Hot and dry, you get a desert. This is the rulebook in action. All right, now that we've got the rules down, let's start our journey. First up, we're diving into the biomes that are just exploding with life, the forests and the grasslands. Our first stop is the tropical rainforest. As you can see on this map, they're wrapped around the planet's middle, right near the equator. Think South America, Central Africa, and Southeast Asia. And the stats here are just off the charts. It's always warm, and they get an unbelievable amount of rain, over 2,000 millimeters a year. Just to give you an idea, that's like 4 times the rain that London gets. This perfect storm of heat and water means they have the highest biodiversity of any place on land. Period. Life here is a fierce competition. The canopy of trees is so thick that almost no sunlight ever hits the ground. Now, you'd think the soil would be super rich, right? But no, it's actually pretty poor. Why? Because as soon as something dies, the nutrients get sucked right back up by all the hungry plants. It's an incredibly efficient system, and it's home to about half of all plant and animal species in the entire world. Just wild. Okay, let's hop over to our next stop, which you'll often find right next door to the rainforests, the tropical grasslands, or as you probably know them, the savanna. Think of the sweeping plains of Africa. So what's the big difference here? Well, check this out. The temperature is just as warm as the rainforest, but look at the precipitation. It's a lot lower, and that one simple change, that single limiting factor, is what stops a dense forest from growing and gives us this wide-open grassland instead. Life on the savanna is all about surviving the distinct wet and dry seasons. Plants have to be really tough, like the acacia tree with its super deep roots that hunt for water. And this is the perfect environment to support those huge herds of grazing animals we all know, like elephants and zebras. Okay, so we've seen where life is abundant. Now, let's take our trip to the edges of that rulebook chart, to the extreme environments where just staying alive is a daily battle. Our next stop, the hot desert. You can see them on the map in places like North Africa's Sahara or in the Australian outback. These are places defined by a serious lack of moisture. The stats really tell the story. The daytime heat is intense, yeah, but the real showstopper, the main limiting factor, is water. We're talking less than 250 millimeters of rain a year. That makes it one of the driest places on Earth, and it's why biodiversity is so low. But even here, life is incredibly clever. Cacti have those pleated stems that can literally expand like an accordion to store water. A lot of animals just sleep through the scorching day and come out at night. And check out the fennec fox. Those huge ears aren't just for listening. They act like giant radiators to get rid of body heat and stay cool. It's genius. Okay, Let's jump from one extreme to the other. From the hottest biome, we're going all the way to the coldest, the Arctic tundra. You'll find it way up in the northern hemisphere, right below the polar ice cap. Now, here is something that might just blow your mind. Look at the precipitation number. It's less than 250 millimeters a year, which makes the tundra a literal polar desert. But the real defining feature isn't the dryness, it's the bone-chilling cold. It's below freezing most of the year, which creates a layer of permanently frozen soil called permafrost. Surviving here is all about beating the cold. Plants grow super low to the ground to hide from the wind, and animals, like the Arctic fox, have thick fur and tiny little ears. It's the exact opposite of the fennec fox. A smaller surface area helps them hold on to their body heat. Everything here lives life in the fast lane during a very, very short summer. So we've seen how climate creates this incredible natural map of life on our planet, but for our last stop, we have to add one more incredibly powerful force to the mix: us. Just take a second and really look at these two maps. On the left, that's the world of natural biomes, drawn by climate over thousands of years. But on the right, that's the map of the world we've built. The red areas are where we have totally changed the landscape for our farms and cities. Scientists even have a name for them: anthromes, or human biomes. We're not just living in biomes anymore, we are actively creating them. And that's the big takeaway here. Between how we change the land directly and how our activities are changing the entire global climate, we are literally redrawing that rulebook chart we saw at the beginning. Biomes are shifting, the map of life is changing right before our eyes. And the huge question for all of us is, what's this map going to look like in another 100 years?